Seventh grade, welcome back. We're in week 15 and we have completed our study of convergent plate boundaries. Today we're talking about continental margins. So as a learning target, we should be able to explain everything about continental margins. Plate tectonics explains why some beaches have lots of cliffs and some do not. Have you ever noticed that? A beach with a lot of cliffs is near a plate boundary. A gentle, sloping, sandy beach is not. There are exceptions to this rule, but it works in most cases. Think of a continent like North America. Surrounding the continent are continental margins. The continental crust grades into oceanic crust at continental margins. Continental margins are underwater. Almost all of North America sits on the North American plate. Both sides of the continent have continental margins, but each is very different. One continental margin of North America is an active margin. The other is a passive margin. Can you guess which is which? If a continental margin is near a plate boundary, it is an active margin. The continental margin of the western North American plate is near a set of plate boundaries. There are convergent boundaries, like where there is subduction off the Pacific Northwest. There is transform plate boundaries, the San Andreas Fault, and the small amount of North American continent that is not the North American plate is across the San Andreas Fault. It is on the Pacific plate. The Western North America has a lot of volcanoes and earthquakes. Mountains line the region. California, with its volcanoes and earthquakes, is an important part of this active margin. Here we see a map of the North American plate. The Pacific plate on the left is an active margin. You can see near California, there is a transform plate. They're passing by each other. Further to the north, there is subduction going on. And all along the western coast, there are volcanoes and a great deal of earthquake activity. Now, look on the eastern coast of North American plate. You'll notice that the eastern coast of the North American plate is not near a boundary. There are no volcanoes and very few earthquakes along the eastern coast of North America. You'll notice on the western coast, there's a picture there of Big Sur in Southern California, and it has beautifully cliff-lined beaches. The reason they have those cliffs is because of the activity of that particular plate boundary. On the eastern coast, you have, for example, here at Daytona Beach in Florida, flat, smooth, sandy margins. Very typical of a passive margin being a margin where there is not a lot of earthquakes or volcanoes. So there are no volcanoes and very few earthquakes on the eastern edge of North America. The continental margin is a smooth transition from continental to oceanic lithosphere. The continental margin there becomes oceanic lithosphere, but both are on the North American plate. There is no plate boundary. The far eastern edge of the North American plate is the mid-Atlantic ridge in the middle of the Atlantic Ocean. The portion of a plate that does not meet another plate has no geological activity. This is called a passive margin, okay? So, in summary, continental margins can be active or passive depending on whether or not they are near a plate boundary. Volcanoes and earthquakes are common at active margins. Active margins are near plate boundaries. Passive margins are, surprise, surprise, passive, peaceful, not active. They have little or no geological activity. So if you are comfortable with continental margins, please feel free to move on to the questions that follow. If not, before you go to those questions, make sure that you stop and see this video one more time. Have a great day. Talk to you later. Bye, guys.